Hello students. So how are everyone? I think everyone hope well. So today in wave motion topic I am going to explain what is intensity of wave, and before that one important formula I am explaining here, and based on that formula one problem. This type of question recently in the 26 NEET paper also given. See, the displacement of particle along y direction given by travelling wave equation or progressive wave equation. See this equation here, y of x comma t, y of x comma t is equal to a sin omega t minus kx plus pi. This is a travelling wave equation or progressive wave equation. See this equation here, y representing displacement of particle along y direction, and here x representing here the wave moving along negative x, positive x direction. So suppose wave moving along positive x means here minus sign will get. Wave moving along negative x direction, here positive sign will get. So like that we can remember this equation, and t means at that particular instant of time t. This is the displacement of the equation here, where a amplitude, we know omega angular frequency or angular velocity, k is the propagation constant, and phi is the phase difference. Okay, next one example problem taking here. The displacement of particle along y direction, y of x comma t is equal to 10 power minus 5 and sine 2 pi into, it is 100 t minus 5x plus 1 by 6. This is the given equation here. But if you are observing this equation with the standard equation, means this above equation, after sine one additional 2 pi we have. That's the first step, we have to multiply the 2 pi with remaining inside the value here. Right, therefore y of x comma t is equal to 10 power minus 5 sine, if multiplying 2 pi here, so this is a 200 pi t minus, so 10 pi x plus 2 pi by 6. So 2 1 ja 2 3 ja cancel here. After that here 10 power minus 5 sine 200 pi t minus 10 pi x plus pi by 3. This is a standard equation form. Next, here different values asking. First bit here, amplitude I am calculating. Amplitude means when comparing this above equation, this equation to this one, in place of a 10 power minus 5 we have. See first bit here, that amplitude A is equal to 10 power minus 5 meter. Second one I am calculating here, wavelength. Wavelength means already we know, this x coefficient is k. See once you hear standard equation, kx we have, it means x coefficient is k. When comparing here, x coefficient k here x coefficient 10 pi given. So therefore, second bit wavelength at all. So x coefficient is nothing but k is equal to 10 pi here. But we know k value 2 pi by lambda is equal to 10 pi. See pi cancel here. So therefore lambda is equal to 2 by 10 means 1 by 5 or 0.2 wavelength SI unit is meter. See like this if you are comparing, so given equation to standard equation, easily we can solve this type of question, shortcut method. And one more here, frequency I am calculating. Linear frequency, angular frequency both are different, but omega is nothing but t coefficient, which is called angular frequency denoting by omega. See now third bit here, So if you are comparing t coefficient, here t coefficient omega, but in the given problem this value 200 pi. This is a angular frequency, but we know omega is 2 pi n. So if you are taking omega 2 pi n is equal to 200 pi, pi cancel, and 2 ones 100 times cancel here. Therefore frequency n is equal to 100 hertz, this value. So this I got here angular frequency and linear frequency. Next fourth bit here. So V I am calculating speed of the sound in air. V is equal to n lambda here. V is equal to n value 100, but wavelength lambda value already got 0.2, 110 decimal cancel, 20 meter per second here. See, we also calculated. But V value, one more shortcut formula we have, V is equal to omega by k. So this one I am taking shortcut method here. V is equal to omega by k. See, once you check here, we know omega is 2 pi n divided by. But what about k here? K we know propagation constant, which is equal to 2 pi by lambda here. If substituting k value here, 2 pi by lambda, 2 pi cancel. Now V is equal to n lambda. So it means for V, we have direct formula n lambda, or we can take shortcut way here, omega by k. Simply remember here, omega is a t coefficient by k, nothing but here x coefficient. So suppose if you don't know, no need to calculate here V value and n value and lambda value. Directly, if you are taking V is equal to t coefficient by x coefficient, we can calculate V. So checking I am here, this value will get correct or not. V is equal to, say once your t coefficient here, 200 pi divided by, what about k value? 10 pi we got. See now pi cancel, 110 cancel, is equal to 20 meter per second. So same thing we got. That's why to calculate in simple way or shortcut way, to V value directly we can take here omega by k. And next in this year 26 NEET exam, so the same question here, find the path difference, phase difference between the two particles are separated by, so 0.5 meter given. See, that's why I told this is very important topic. In every year we can expect one question based on this topic, traveling wave and progressive wave or stationary wave. Out of these two topics, one question asking in every year. So here see once you, delta x already given. So delta x is equal to 0.5 meter, but phase difference we have to find. The two particles are points separated by distance 0.5 given, and we know the relation here, phase difference is equal to 2 pi by lambda into path difference. So 2 pi by lambda, nothing but this value is k only. It means see, indirectly k value we have to substitute here. See, easy way, what I told before, k how we can remember, x coefficient is nothing but k. See, x coefficient how much given here? 10 pi. In place of 2 pi by lambda, so I am substituting here 10 pi, and this difference, path difference 0.5 given, which is equal to this 10 and point cancel 5 pi radians. This is the phase difference between the two particles. So like this way we can use this formula, traveling wave equation. And now intensity of wave, one small topic I am explaining. See, first for intensity of wave, energy I am calculating, energy of the wave. After that intensity easily we can calculate. So energy is equal to half into mv square. Here velocity of the particle means, so differentiating displacement of the particle with respect to time. So velocity you can calculate, that v substituting here, easy way will get answer. Okay, see that all I am following here. See first here energy of wave I am taking, energy of wave. So I am taking here E. That energy of wave E is equal to